Again, welcome to DSRT 734 class, Inferential Statistics in Decision Making. In these lectures, we're going to study by the basic concept of probability. So our objective is to identify what is a sample space of a probability experiment. Also, we should identify simple events and also how to use the fundamental accounting principles. We should also distinguish among the classical probability, empirical probability, and subjective probability. Then we're going to determine the probability of the complement of an event and also learn how to use the tree diagram and also fundamental accounting principles to find probabilities. So first we will go through some few terminology. So our first terminology is what is a probability experiment. So a probability experiment will be any action or a try through which specific results. The result will be based on counting, measurement, or responses are obtained. Second is outcome. Outcome will be a single result in a probability experiment. So we did a probability experiment to toss a coin. When I toss a coin once and I get head, head is an outcome. So it had to be the result of a single try in a probability experiment. Sample space will be the set of all possible outcomes of a probability experiment. So tossing a coin, the sample space will be head and tail. But for the outcome, it has to be either head or tail, not both. So event also is what normally takes place. And anytime something takes place, we have to get a result at the end of it. So event consists of one or more outcomes, and it's a subset of the sample space. So let's see one example on probability experiment. Our experiment is to roll a die. When we roll a die, there are possible 6 outcomes, but our outcome here is 3. And the sample space will tell us all the possible outcome from 1 to 6. And then we have one event that only the die will be even, the side that will come will be even, and we only have 2, 4, 6, 3 even numbers. So this is again the concept of probability experiment, outcome, sample space, and also event. Now identify the sample space. A question is given here. A probability experiment consists of tossing a coin and then rolling a 6-sided die. Describe the sample space. The sample space here will be the possible, again, outcome of this experiment. So the first outcome will be rolling a 6-sided die. Then the second outcome will be tossing a coin. So the possible sample space, which is the total outcome, will be 2 for head and tail, 6 for die, 1, 2, 3, 4 to 6. So let's see the solution. There are 2 possible outcomes. When you toss a coin, you either get head or tail. And then for each of these, there are 6 possible outcomes. When you roll in a die, you either get a side 1, 2, 3, 4, 5, or 6. Now, one way to list the outcome for action occurring in a sequence is to use the tree diagram. Or another way is using a multiplication. So if the possible side for the coin is 2, and then the die is 6, then we say 2 times 6 is 12. That would be the possible outcome. So that's the tree diagram. We have the head, 6 possible outcome, the tail, 6 possible outcome. So by using multiplication rule, we get 12 outcomes. 2-sided for coin, 6-sided for die. So 2 times 6 is 12. So what is a simple event? Simple event is something or an event that consists of only single outcome. Or it can be something, event that again have only one result. So an event that consists of a single outcome. Example, tossing heads and rolling a 3. We have one outcome, H3, the head and 3. So an event that consists of more than one outcome is not a simple event. So example, tossing the heads, by this time we are rolling an even number. We have 3 different even numbers. So this is not, again, a simple event. We have 3 events here, H2, H4, H6. So next, we should identify the simple event. We should determine whether the event is simple or not. So you roll a 6-sided die. Event B is rolling at least a 4. So this is not a simple. So this is not a simple event. Why? Because event B is rolling at least a 4. Since the die have 1 to 6, at least 4 means we're going to have a side 4, 5, 6. So again, simple event is only one outcome. Here we have 3 outcomes, either 4, 5, or 6. So it's not simple event. The next is the fundamental counting principles. We saw that example with rolling a die and tossing a coin at the same time. When I roll a die and toss a coin at the center, the possible outcome or the sample space will be the number of side for the coin is 2. The number of side for the die is 6. So it will be 2 times 6, which is 12. And that's what they are telling us here. If one event can occur in n ways, just let's say 2 ways for the coin, and the second event can occur in n ways, let's say that is the row 6 ways, then the number of ways the 2 events can occur in sequence is m times n, or 2 times 6. So that's the principal counting principle. Fundamental counting principles. The m ways and n ways, so we get m times n ways. This can be extended for any number of events occurring in sequence. So this is example here. You are purchasing a new car. The possible manufacturer's car size and colors are given. The manufacturers are Ford, GM, and Honda. The car size is either compact or mid-size. And the color again is white, red, blue, and green. So according to the fundamental counting principle, the sample space or the possible outcome will be 3, which is 3 manufacturers, times 2, which is the outcome for car size is either compact or mid-size, then times 4, which have 4 different colors. So we get 3 times 2. Let's give us 6, then 6 times 4 will give us 24. So we can see the answer 3 times 2 times 4, which is 24 ways. So also using the tree diagram, we can see we start with the Ford, GM, and Honda. How many Ford we have? Only 2 sides. So compact mid-size, compact mid-size, compact mid-size. Then we have how many sides? 8 together. So that's why we get 8 plus 8 plus 8 at the bottom. And that will give us 24 ways. So next we go to the types of probabilities. We have a classical probability, empirical, and subjective. Classical probability is deal on more or less like finding relative frequency or proportion of something. So each outcome is a sample space is equally likely. So probability of E is the number of outcomes in event E divided by the number of outcomes in sample space. So this is like looking for part of something or proportion of something. So that's why we say classical probability is the same as the concept of relative frequency. So the number of outcomes in an event divided by the number of outcomes in sample space. So a very simple example would be we have 10 apples, 6 red, 4 is green. What is the probability that we are going to pick again red? Since red is 6, it will be 6 over the total, which is 10. So that's the concept again of classical probability. So rolling a die, tossing a coin, these are all classical probability because their outcome doesn't depend on the previous result. So that's another way of putting classical probability. The result we get at present or was not determined or cannot be predicted based on the past result. We cannot. So an example here of a classical probability, they say we should roll a 6-sided die and find the probability of each event. So event A, we roll a die 3. Event B, we roll a 7. Event C, we roll a number less than 5. So to find the probability of each event, rolling a 3 means I have a die, the possible side is 6, and I have only 1 3, so it will be 1 over 6. Event B is rolling a 7. We have from 1 to 6, so rolling 7 is impossible. So let's see the result. Sample space again is 1, 2, 3, 4, 5, 6, the possible outcome for rolling a die. So it's between 1 to 6. So first, rolling 3 means we have only 1 3, so it will be 1 over 6. Then event B, rolling a 7, we don't have no 7 from 1 to 6. So here we say 7 is 0. Then next event C, they say rolling a number less than 5. If it's less than 5, then it will go 1, 2, 3, 4. And that's what we have here. So it will be 4 over total, which is 6. So next we go to the second one type of probability. This is empirical probability. Now the classical probability means the present result doesn't depend on the previous result. So we find the probability based on the present data. With empirical probability, we are going to get our result based on the past experience. So based on observation obtained from probability experiments. So relative frequency of an event. So probability of E will be the frequency of event E divided by the total frequency. So here we don't say how many times it comes. So this example gives me a company is conducting an online survey of randomly selected individuals to determine if traffic congestion is a problem in their community. So far they have 320 people have responded to the survey. What is the probability that the next person that responds to the survey says that traffic congestion is a serious problem in their community? So here we know the values here are giving a serious problem, moderate problem, not a problem, 320. And so far 320 have responded to the survey, and this is their result in the table. Now the question is, what is the probability that the next person that could respond to the survey says that traffic congestion is a serious problem? So traffic congestion, the congestion is a serious problem. The number of times was 123. So this means our answer will be based on the previous result here, 123, then divided by the total now, which is 320. So that's like finding the relative frequency also. But our result is based on previous answers given to us. So next we have the subjective. Here we didn't discover subjective probability concept is that we cannot quantify the outcome. So for example, what's the probability that New York Knicks will win the World Series? Yeah, we cannot say that, okay, for the past 10 years, New York Knicks won 5 out of 10. So the probability of winning this year will be 5 by 10. No, we cannot say that. That's why it's subjective. So what's the best way? We have to consider the conditions. Is New York Knicks have a good coach this year? Do they have a good players this year? The morale is very high. If that's the case, then there's higher probability that they will win the World Series. Otherwise, they are going to lose it. So subjective, again, is intuition, educated guesses, and estimate. And the good word is educated guesses. In New York Yankee example I'm giving is based on my background, educated guess. Because now I know New York Yankee have good players, they have good coach, they are increasing their bonuses for their players. So these are all positive scenario. So subjective, again, there's no calculation. It's based on our education background, your intuition, educated guess, or estimate. So a doctor may feel a patient has 90% chance of a full recovery. Now, classify types of probability. Here we have a question saying, classify the statement as an example of classical, empirical, or subjective probability. The probability that you will be married by the age 30 is 0.50. So this will be subjective probability. We are going to have educated guess. Now, second, the probability that a voter chosen at random will vote Republican is empirical. So it's based on previous experience, most likely based on a survey. Then the probability of winning 1,000 ticket raffle with one ticket is 1 by 1,000. So classical probability means equally likely outcomes. And now we have some few rules of probability. The first is the range. The range of probability means what kind of values we can assign to probability. Normally it will be from 0 to 1. So the probability of event E is between 0 and 1. Inclusive. Inclusive means including 0 and 1. So this example here, we have even chance, the middle, likely, certain, to the right, unlikely, impossible, to the left. Then the second is the complement events. So we said a set of all outcomes in a sample space that are not included in event E. So if I have event E here, then the rest of the universal set will be in not event E. So this is complement. The apostrophe is complement. So we donate it by E prime. So the total, we know that we were told that probability value should be from 0 to 1. 1 is the maximum. So the probability of E not complement and complement is 1. Because the total probability is 1, and this should be valued between 0 to 1. Then the probability of E will be 1 minus probability of not E, or complement of E. Then probability of complement of E will be 1 minus probability of E. So here we have a question. They say probability of the complement of an event. We survey a sample of 1,000 employees at a company and record the age of each. Now, here they say we should find the probability of randomly choosing an employee who is not between 25 and 34 years, is not between that age. So here we have from 15 to 34. So it will be from here 35 down. So here we say the age from 25 to 34, the total will be 366. And we know the total frequency is 1,000. Excuse me. So it will be 366 divided by 1,000. Then using the complement rule, we will say 1 minus 366 divided by 1,000, which will give us 0.634. So probability using a tree diagram, we saw this example by tree diagram, which is the concept of multiply all the possible outcome. So a probability experiment consists of tossing a coin and spinning the spinner shown. The spinner is equally likely to land on each number. So we should use a tree diagram to find the probability of tossing a tail and spinning an odd number. So here we know the tree diagram, tossing a coin is only 2 possible outcomes. And for the tail, let's go back here. For the spinner, we have 8 sides, 1 up to 8. So that's why here again, we have the head or tail. Then the second part should be possible 8 from H1 to H8. And then from T1 to T8. So this will give us again 4/16 or 1/4. Why 4/16? Because we know the possible outcome is again 16. Then we have, based on the question, we have 2, 3, 2, 1, T5, T7. So we get 4/16. And the possible outcome we can see from the diagram, 8 to the left because 8 spinners, head will be 8, and also tail will be 8. So we get 16 total sample space. Again, example is given here, probability using the fundamental counting principles. So here, your college identification number consists of 8 digits. Each digit can be 0 through 9, and each digit can be repeated. What is the probability of getting your college identification number when randomly generating 8 digits? So first, each digit can be repeated. And we said there are 10 choices for each of the 8 digits. So using the fundamental counting principles, we can get 10, 10, 10, 8 times, which will be 10 to the power 8. So again, here we can see each digit can be repeated. There are 10 choices for each of the 8 digits, spinning 8. So using fundamental counting principles, we can say 10 8 times. Since there are 10 choices and it can go up to 8, so it will be 10 to the power 8. And then only one of those numbers correspond to your ID number. So probability of your ID number will be 1 over 10 to the power 8, which is again 100 million. So again, we're going to end the lectures here. In these lectures, we study about the basic concept of probability. And we went through only 2 rules so far. And the next lecture, we will continue with our probability, going through more rules. So the rules we learn here, again, is that probability values should be between 0 and 1. And the complement of a probability will be 1 minus that probability. So again, wish everybody the best, and thank you.